Hello friends.
Hello, sir.
Hmm.
Hello, sir.
So can you see my screen?
Yes, sir.
Okay. So let's start today's session with a numerical. Take out your pen and notebook and write down the question. Question is 2 mole of ideal gas is heated from okay. So 2 mole of ideal gas is heated from 300 Kelvin to 600 Kelvin. Hello, is my voice audible?
Yes, sir.
Yes, sir.
Actually, I'm hearing some noise. Wait, let me close applications. And find change in entropy. Now, just you have to use the formula and solve this question. Can you do this? You have to use this formula. Use this formula on the screen and solve the question. The ideal gas taken is monoatomic. This is also given. This is required to solve your question. That's why. Are you solving it? Hello? Are you trying to solve this?
Yes, sir.
Uh, What is the CV of monoatomic gas? Anybody? Hello. Check out this question. See, I'm giving you some hints. So N is given, right? 2 mole.
Yes, sir.
Yes.
R is already known, and volume is V2 by V1. V2 V1 given. This is V2. This is V1, right? And N is given. CV. Anybody comment on CV? Hmm? For monoatomic gas, I'm giving you a hint of monoatomic gas. What is CV? C of monoatomic gas, you have to remember, because it can give you, but in this problem, monoatomic gas CV is not given. So monoatomic gas CV is 3 by 2 R. Okay, for monoatomic.
Yes, sir.
And for diatomic, anybody? For diatomic, 5 by 2 R. Okay. So in this question, examiner has not given what CV you have to put. So he wants you to know this thing already, and you have to put all the data in this. So I'm going to solve this. Kindly look here. I'm going to solve this. So N is 2. R we are keeping it is at as R only. Ln V2 by V1, 4 by 2, right?
Yes.
Plus N is 2. CV we are putting it as 3 by 2R. And Ln T2 by T1, 600 by 300. Okay. So this is being cancelled out of 2. This is also cancelled 2. So 2. Acha, R will be taken as 2 here, because in cal, if we will if we want to find in calorie, so we will directly put R as 2. In calorie, you know, R value is 2. Hmm?
Yes, sir.
And in joule, 8.314, right?
Yes, sir.
Hmm. So 3 into 2 ln 2. So 4 ln 2 plus 6 ln 2, 10 ln 2, right?
Yes, sir.
Uh, so calorie, Kelvin. How this is the unit? Delta is equal to Q by Tc. S is equal to Q by T. If you have remembered, S is Q by T. So Q will be either in calorie or in joule, and temperature, Kelvin. So the unit will be joule per Kelvin or calorie per Kelvin, right?
Yes.
Uh, so I hope you can solve this question. Hello.
Yes,
Yes,
sir.
sir.
Take. Now we will try to solve more question. Uh, Write the question this. Enthalpy change. Write down the question. note down the solution who have not understood this, and if you have problem, I can repeat and explain you if you are having doubt. Any problem in this question? Any step?
No, sir. No problem.
Enthalpy change for I'm reading out the question. Kindly write it down because my laptop is being little slow. Enthalpy change for transition of liquid. Hello, everybody is noting down the question.
Yes, sir.
Yes, sir.
Enthalpy change for transition of liquid. Transition of liquid water to steam. Transition of liquid water to steam is liquid water to steam is 48 40.8 kilojoule per mole. Okay, at 373 Kelvin. Okay, you have to calculate delta S of this process. Okay, have you written the written down the question?
Yes.
Try to solve this. You have to use the above formula. Which formula? Just think it by yourself. Which formula I'm talking about? Can anybody say which formula we have to use here? Hmm? Anybody? Earlier I was saying that sir has already taught you enthalpy of fusion and enthalpy of vaporization and all. Means it was not skipped. It has been taught to you. You have to use this formula. See, I will explain you. You have to use this formula. See, the question is, hello, are you, everybody is listening?
Yes,
Yes,
sir.
The question is the enthalpy change for transition of liquid, right? The enthalpy change of the transition of liquid is given. So the heat exchange is already given in this question, right?
Yes, sir.
Enthalpy
Yes,
change is a heat change only. So there should be no doubt. So enthalpy change is given, and at that temperature is also given where the water is turning into steam. So you have both data. You want the examiner wants you to find delta S, change in entropy. So directly you have to use this formula only. Have you understood this? This is a very simple thing. This is the one of the most shortest formula. Delta is equal to Q by T. You have to put enthalpy or any heat involved in it, and then you have to divide it by the temperature at which the process is happening, and you have to find the delta S. By this way you can get the change in entropy. So kindly find it out and let me know what you are getting the answer. You can round it off also. Yeah, you tell me in the fraction form. Can everybody relate it with formula? The question with the formula? This is very important thing. $110. Yeah. Anybody else? You can ask the question. This is the time. If you are not getting, not the answer you are getting, I'm asking that you can relate the question with the formula. This is very important, that you have to understand the question. Then you can understand that which formula we are going to use. So most of the people have given the answer. So let's try this out. So delta S will be change in you know change in sorry transfer of heat. So the heat involved in this is 40.8 kilojoule per mole. So we will put directly it as 40.8 kilojoule per mole. Okay, since this is kilojoule, we will add multiplied by 10 power 1000. So it will be converted. Now we will divide it by 373 in Kelvin. The examiner can give you 100 degrees Celsius. So you have to convert it first in Kelvin, then you will need to solve this out, right? So finally, your answer will be around of 110, 110 joule per Kelvin. If you will write it as somebody has written the answer like zero point 0.1 kilojoule per mole, that is also properly correct. So you have got the answer. So I got the answer from like 5 people. Good. So this one is one of the easy question. Okay, now let's give you another one. Acha, let's give me this. I'm writing this question. Do anybody have any problem in this question? He can ask it now.
No, sir.
Anybody? See
No,
these
sir.
these questions are very simple, and just you have to put it in the formula. This formula is very short. This formula is big. However, you have to put the formula, the values in it, and you will get the answer. Kindly write down the question also, because if you will not write the question, then later on when you see your notes, you will also only see the solution, and with no question you cannot relate it what you have done exactly. So in this question, enthalpy of vaporization of this liquid is given. There are two parts in this question. One is asked that you have to find the enthalpy for liquid to vapor conversion. Okay, and another vapor to liquid conversion. Now try this out. The formula will be same, but here you will get some new things also here also. Try this out and don't fall into silly mistakes. Have you people solved the question? Adil, Abir Adil,
Yes, sir.
uh, have you solved the earlier questions?
Yes, sir.
Or are you trying to solve this?
Yes, sir. I'm solving the second one.
Okay. Giobita,
Yes, sir.
so are you understanding the problems?
Yes, sir.
Okay, so are you solving this last question?
Yes, sir, I'm doing.
Okay. Sabiha, I'm not getting any response from you. Are you understanding the question? You can ask it now. I will repeat it for you. Maybe I will explain it in another way. You just have to ask. Sabiha, are you understanding?
Yes, sir.
Okay. Shaima,
Yes, sir.
so you are getting answer 0.742 and 2600, right?
Yes, sir.
Kindly try again. Ali Muhammad. Ali. Okay, okay. So are you stuck somewhere? Only two people have given answer. Don't worry for the fraction thing. Let it be. Don't have to, solve it. You have to solve it, but that's not important here. You have to understand the concept. That's more important. Alina,
Yes, sir.
so are you having problem?
No, sir.
Okay. So 84.4. See, you are writing in like in this way. You can say it also. There is no issue in that. So Abir has got the right answer. I don't know. You people have done some silly mistakes. So that's why you are getting wrong answer. Yeah. Shama, you have done some silly mistakes. That's why you're getting wrong answer. Rest Jaslyn and Abir are doing good. Only first option. Try the second one. And now I'm going to solve the question. You can look here. Wait, what is happening? See, in first case, who is messaging? Okay, good. So in first case, we are converting liquid into vapor. So enthalpy of vaporization means energy, the heat energy given to the liquid to evaporate, evaporate it, right? Completely evaporate it. That is called enthalpy of vaporization. Amount of energy required to vaporize the liquid. And what is enthalpy of fusion? Amount of energy required to, convert the this liquid into solid, to fuse the because in the question enthalpy of fusion can be asked also. So regarding enthalpy of vaporization, it is given as 26 kilojoule per mole, and its boiling point and melting point is given, right? So let me tell you, this melting point is only given for confusion. There is nothing related with it with here, because we are converting liquid into vapor. There is no solid thing is there, right? Is everybody understanding this question?
Yes, sir. Yes, sir.
So where were we? So by formula, we know delta S is equal to Q by T, and here Q, which is the heat involved in it, is 26 kilojoule per mole. Okay, and the temperature is given as 35 degrees Celsius, but the temperature is given in degrees Celsius. So we have to convert in Kelvin, otherwise we will get the wrong answer. Because in thermodynamics, let me tell you, in thermodynamics, nearly everywhere we have to solve the temperature in Kelvin, not in degrees Celsius or in centigrade, Fahrenheit. So 35 plus 273. So we will write as uh, so we will write it as, oh, a second, 308, right? And we will solve it, and we will get 84.4 as joule per Kelvin, right?
Yes, sir.
So first part, I think most of the students have done this, except means somebody have done blunder mistake of taking temperature as 35. So you understand this point, everybody?
So the
Hello, I am
first,
talking to everybody, not some few students
so
who
the
are.
first, it should be negative, right?
See, enthalpy of vaporization is that we are giving heat. We are giving heat so that water can evaporate, right? Sorry, this liquid can evaporate. So
Yes, sir.
Q will be positive only, because in thermodynamics, first or second class, you may have known from the sign convention that if we are giving heat to the system, then Q will be taken as positive, right?
Yes, sir.
So we are giving heat to the liquid, and liquid is getting evaporated. So Q will be positive, okay?
Yes, sir.
And here delta S for vapor into liquid. So if vapor is converting into liquid, so heat is released from that heat, right? It will release heat. So Q will be negative of this. Like if, like for example, if anybody is having some doubt, let it be ice, okay? So if we give it 2 kilojoule, it will melt, completely melt. Okay, we are taking example only. Okay, so if we extract 2 kilojoule now from here, it will then convert into ice. This is the process. This is a cyclic process actually. Are you getting it?
Yes, sir.
So it will convert into ice. So same thing is here. We are giving 26 kilojoule to 1 mole of this liquid. Let me put on the charger. So so this much amount of heat, if extracted from this 1 mole of this liquid, then it will convert into liquid. Okay.
Yes, sir.
So this will be minus times of 26 kilojoule per mole, and rest will be same. Temperature, the temperature is given 35 degrees Celsius. So 308, and the rest will be minus times of 84.4 joule per Kelvin. right?
Yes, sir.
Have everybody understood this?
Yes, sir.
Good. So, okay, good. So I think you can solve these simple numericals. Anybody with having any doubt? Mhm. Okay. So one thing I want to let you know that this if delta S is positive, okay, in a reaction, if delta is positive, then the reaction will uh, go on, and it will be a spontaneous process. Okay, delta is total. Wait. But if delta S total is negative, the reaction will be non-spontaneous. Yeah, the process will be non-spontaneous. If special case, if delta S total will be 0, then the process will be at equilibrium. Process is at equilibrium. You understand equilibrium?
Yes, sir.
The reaction is not completely getting in forward direction or backward direction. So it is at equilibrium. Okay. Okay. Now we will see second law of thermodynamics. Second law of thermodynamics. So second law of thermodynamics says that any spontaneous reaction, entropy of universe will always increase. Like any spontaneous reaction, you understand spontaneity. We have discussed it, which happens it by itself or with a little push. Do you remember?
Yes, sir.
So this second law of thermodynamics says that any spontaneous reaction any spontaneous process always increase. Okay. So since it is happening by itself, so the entropy of universe will always increase. Okay.
Yes, sir.
Now we will introduce a new term, Gibbs free energy. Gibbs free energy. Gibbs free energy. It is named after a scientist named Gibbs. Gibbs free energy. Actually, in theory part, you try to understand that, like for example, you can say if we are burning some coal, Okay, and using it to move the turbine and used to produce electricity. Okay, this is what happens in uh, power plants, thermal power plants, right? Actually, you don't know anybody? Hello,
Yes.
anybody know what is thermal power plant?
Yes.
Zainab, are
Yes,
you
sir.
there?
Yes,
What,
sir.
you know what is thermal power plant?
It's used for electricity purpose.
Yeah, actually, thermal power, in power plant, electricity is generated, and from thermal power plant, it is when the coal is burnt to move the turbine to produce electricity. Like hydroelectric power plant, the in dams, when to move the turbine, we are using the uh, flow of water to move the turbine, and if when the turbine is moved, electricity is generated. So what I was saying, so when you burn the coal, heat energy is released and electricity is generated. However, when you this amount of electricity is not equivalent with the heat produced by the coal. So finally, what we are trying to say, that every heat cannot be converted into all work. Total heat cannot be converted into total work. Okay, because there are some heat are lost somewhere in real world. Heat is lost somewhere. There is no some nothing like 100% energy efficient. Okay, like there is engine which is in bike or in cars, so it is not 100% efficient. And we cannot make it 100% efficient because there are some energy losses. Okay, so that is called useful energy, and some is non-useful energy. Okay,
Yes,
I'm not
sir.
getting any responses. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
So are you understanding what is means what is useful energy, what is non-useful energy? Energy which can be 100%, it can be used 100%, is useful energy. Energy which cannot be used because there will be some loss, so that is called non-useful energy. Okay.
Yes, sir.
Mm.
Yes, sir.
So like you have to know this ki, in gives free energy. Energy, what is gives free energy? Energy of system which can be used, energy of system which can be used, which can be used as useful work. So this is the energy which can be used as useful work. The rest energy is non-useful. So what is non-useful work? Means what is happening actually? So the randomness which we have talked about, the randomness, more the randomness, more the non-useful energy. Because in this randomness thing, energy is being lost. Okay, are you getting it? The
Yes.
randomness of the thing which we have talked earlier. So in their randomness, energy is being lost. So that is non-useful energy, which is being lost by itself. And useful energy is can be used by us. It can be transferred. Okay, so that energy is known as Gibbs free energy. Okay.
Yes, sir.
Yes, sir.
Regarding G, it is generated by G. I have to write G. So it is a state function. We have already talked about it last time, and it is an extensive property. Means it depends upon mass, right? Its formula is G is equal to H minus Ts. This is the formula. Okay. What is H? Enthalpy. T, temperature. S, entropy. Okay. Are you getting
Yes,
it?
sir.
Huh. So let's derive this formula. So let's take this as a system, and there is some surrounding. Acha, you already know that H is defined for at constant pressure, right?
Yes,
Good. Just for your knowledge. So in surrounding, T and P are taken as constant. Okay. So now delta S of universe, uh, change in the entropy of universe will be equal to change in entropy of system and surrounding. You already know that system plus surrounding is universe, right?
Yes, sir.
yes,
So and this the manipulation you see here, S is converted into Q by T. Okay. Wait, let me. Hmm. See, uh, delta H of system is equal to minus delta H of surrounding. How? The the heat given by surrounding is absorbed by delta H of system, because in universe there are two things only, system and surrounding. So surrounding heat is transferred to system, so it will be completely opposite with opposite sign. Okay. So delta S of surrounding is equal to delta H of surrounding upon T, right? By the formula delta H is equal to Q by T. Okay. Are you getting it?
Yes.
Yes, sir.
So delta S of surrounding, we are replacing this with this one. So delta H of surrounding is minus delta H of system, right? We have replaced this one here. Okay. Delta H of surrounding is minus delta H of system, right? Any problem? Hmm.
Yes, sir.
Okay. So now the main formula delta S of universe is equal to delta S of system plus delta S of surrounding. Delta of S of surrounding is minus delta H of system upon T, right? Till here well and good.
Yes, sir.
Hmm. So we are multiplying T with every side. So T of delta S universe is equal to T of delta S of system minus delta H of system, right? Are you what we have done? We have multiplied T with every option. Okay. Now T we are getting T delta S. So we are doing this delta H of system then finally T delta S of universe is equal to minus delta G of system. See what happened. Why we have eliminated this surrounding thing? Why? Because we have the knowledge of system only. What is happening with the system? What is delta H of it? So we have replaced this. So finally we get T delta S is equal to G of system. Okay. Okay. Are you getting it? This final step, this just we have to go through all steps. You don't have to remember the steps. Okay. Just I'm showing it. Okay.
Yes, sir.
Hmm. So that is it. Uh, we will do some questions and we will we will find delta G of some systems. We will put the formula and we will get the answers. One more thing you have to add, that for spontaneous, just have to note. For spontaneous reaction, delta G must be less than 0. Okay. And for non-spontaneous reaction, delta G will be greater than 0. And for equilibrium, same thing. For equilibrium reaction, delta G will be equal to 0. Okay. Now I'm giving you much feel of it. Delta G is equal to delta H minus T delta S. See, delta S, what is this? Randomness, right? This is about randomness.
Yes.
So this is like delta S is equal to Q by T. So T delta S is equal to Q, right? So this is non-useful energy. Non-useful energy. Okay. So we are done. Now I'm giving you some questions. Hmm. Write down the question. You have to just put this in formula and you will get the answer. Only formula based question. You don't have to do anything. Uh, just put the data in the formula and you will get the answer. Every data will be given. You just have to put the data in the formula and you will get the answer. You just have to recognize the data. So change in enthalpy means delta H is given and delta S is given, right? What is delta G at solve this? Is everybody trying?
Yes.
Yes.
You just have to put the data in the formula. You will get the answer. You have give the delta H is also given, T is also given, delta S is also given. Done. Okay, got one answer. So see the question. Uh, enthalpy and delta is given. So delta H and delta S is given already, right? So it is asking what is delta G at 27 degrees Celsius. So first of all, it is given 27 degrees Celsius. We will convert this into Kelvin, right? So 273 plus 27 will be 300 Kelvin, right? Has anybody missed out and written it as in degree only, degree Celsius only, and solve the question?
No, sir.
Okay, good. So now what we will do, we have delta H with us and we have delta S with us. So directly we will use the formula because there we don't have to do much conversion in it. So delta H is given as 40.63 kilojoule per mole. So see, we have kilo here. So we will write it as kilojoule only. So 40630 joule per mole. Anybody having problem with this?
No, sir.
Okay, good. And by the formula minus T temperature is 300 into delta S is given as 100, right? So simple 40630 minus 30,000, right? So finally the answer will be 10630 joule, right? So the answer is in positive. Am I correct?
Yes, sir.
Ah, so what will happen? We will, since this is positive, and we already have told that if delta G is positive, the reaction will be not possible or non-spontaneous, right? Hello.
Yes, sir.
Yes, sir.
Now try this question out. So this one is very easy. Just you have to put the formula. Uh, if the question is in gives free energy na, or spontaneity thing. So you don't have to worry about it. Just put the formula and put the data in the formula and you will solve the question. Try this one question. So anybody? Shaima has sent me the correct answer. So tell me what delta G should be so that the reaction will be non-spontaneous.
Greater than 0.
Yeah, it should be greater than 0 or positive. Okay. So let me ask. Jovita,
Yes, sir.
are you having some problem?
No, sir.
You just have to put the data in the formula. That is it.
Yes, sir.
There are some issues like degree centigrade to Kelvin. You have to convert it. Or if there is some kilojoule present, you have to convert in joule. Or if both are in kilojoule, then no problem. Means you have to make the same unit. Alina,
Yes, sir.
any problem?
No, sir.
So give me the answer. You don't have to do much calculation also. Ali,
Yes, sir.
so what is happening there? You are having some problem? So I'm going to solve this. Kindly look if you are having some trouble. So we will we have to find whether the reaction is spontaneous or not. So we will just we will put delta H minus T delta S. Delta H is given as minus 11.7 into 10 to the power of 3. Okay, kilojoule, sorry, joule per mole, and there will be a minus T. T temperature is 25 degrees Celsius. So we will add 273. So we'll get 298, obviously 298, and delta S is given as minus 105. Okay, so to solve this, we will write it as this minus, we will solve this 298 into 105. So what is coming? 298 into 105. You have solved this now, Zainab?
Yes, sir.
Shama, you also got the correct answer. What is it?
31,290.
31,290 with a positive sign, right?
Yes, sir.
So finally the answer will be 19590 with a positive sign. Since this is positive, you don't see this is 31,000, this is 11,000. You don't have to in MCQ, you don't have to finally write the answer, because you can already see that this is a non-spontaneous reaction. The answer will be in positive only, right? So since this is positive, so reaction will be non-spontaneous, right?
Yes, sir.
Yes.
Good. Only this you have to cover. Try the next question. Try the next, next question. Jesslyn,
Yes, sir.
what you will do in this question? Any idea? Hmm? Any idea with this question? You have to use this formula only. You have to use this formula only. Are you getting any idea? Hmm?
Yes, sir.
So what is your idea? You only say yes sir, no sir. Alina,
Yes, sir.
so what do you think? What we have to, how we have to proceed in this form question? No idea. Hmm? So in this question, see, I'm solving this. This is calculate the temperature of the reaction will be in forward direction. Okay, so we want this reaction to happen in forward direction. Means we want this reaction to happen, to be spontaneous. Means delta G should be greater than 0, or at least minimum it should be equal to 0, right? If it will be equal to 0, then it will be at equilibrium, right? Are you getting my point?
Yes, sir.
Yes, sir.
Yes. So we will again write this formula. So delta G, we will take it as 0, or you can take it as le. Tell me if this is the condition, will the reaction will be in forward direction, since we have taken this as less than 0, right?
Yes, sir.
So delta H is given as minus 95.4 kilojoule. Okay, minus T delta S. T is not given. We have to find the T, and delta S is given as minus 198.3, right?
Yes, sir.
So we will solve this 95.954 T. Acha, this will be with minus sign. Acha, minus minus will become plus, right? This minus and this.
Yes, sir.
198.3. Solve this for T. Okay. 95400 upon 198.3. This should be greater than, T should be greater than this value, right?
Yes.
So the value doesn't matter. That is the mathematical calculation only, and you can means you cannot skip an exam, but here you have to understand it. So this will come as for around 480 Kelvin. Okay. So temperature should be at least equal to 480 Kelvin, right?
Yes, sir.
Yes, sir.
Are you getting it?
Yes, sir.
Okay.
Yes.
So anybody have problem in this question?
No, sir.
Hmm. A small question. This one is theoretical. Delta H, delta S is given as positive. Okay. Is given as positive. In what condition? In what condition reaction will be spontaneous? Spontaneous. Can anybody comment? See, since time is lesser, see, delta G is equal to delta H minus T delta S, right? So delta H is positive here and temperature is not given. Delta S is also positive. Okay. Are you getting?
Yes, sir.
Yes, sir.
To make delta G negative, shall we not increase temperature very high so that this overall effect of this will dominate over this? Are you people understanding this?
Yes, sir.
To make delta G negative, we have to make delta G negative because we want reaction to be spontaneous. So if delta H is positive and delta S is also positive, so we will make temperature so high that overall negative value will become higher than this positive value, right?
Yes, sir.
So in this way, our delta G will be negative and reaction will be spontaneous, right?
Yes, sir.
Okay. So I hope you understand this point. So anybody having any doubt in this formula, in any numerical which we have discussed today? Any means anybody is having any doubt? I can repeat, no problem with that.
No, sir.
Please remember, just you have to use the formula and you have to use the logic that delta G should be negative for a spontaneous reaction. And that is it. And you have to use your mathematical calculation and that is over. Okay.
Yes,
Yes,
sir.
sir.
Okay. So it is